Okay, let's continue on question 4. So question 4 will compute the correlation between so for question 3 we did a visualization on how strong the relationship is, but often the visualization cannot really give you like a solid number, so we're going to compute something to quantify the relationship. So we're going to compute the correlation between the 4 things, and then we're going to answer a few questions, okay? So to do the correlation, we do analyze and then correlate, and then because it's bivariate, so I'm going to do bivariate, and we're going to select all 4 of them. And then let's just do the typical Pearson's correlation, and then let's do OK. So let's just take a look at the correlation. So for example, here it's basically a 4x4 matrix. For example, you see the correlation between internet and internet is 1. Internet and GDP is 0.4. Internet and log GDP is also 0.4. Oh, that's strange. It's really strange. That is such a unlikely coincidence, because I have same correlation between, okay, let's take a look. Compare this two. So internet versus GDP. Internet versus I have 0.804. That's pretty high. And then log versus log, I have 0.4. Okay. So actually, in my case, after transformation, the correlation actually dropped. But this might not be your case because our data is different. Okay, so keep that in mind. So here it also asks you. Oh, they didn't ask you to compare. They ask you whether the sign and magnitude confirm. So here the sign, all of them are positive, which we are seeing here. They are all positive relationship, and magnitude-wise, they are all pretty strong, like 0.8 and 0.7, which is similar as what we saw here. Okay. Okay, that's question 4. Question 5 is pretty long. Let's finish question 5 first. So for question 5, we are doing a linear regression. So we're finally doing a linear regression of internet use on GDP. When they say something on something, and the first term is your real y, and the second term is your x. Okay, so the first part, 5a, asks you to define the model. When they ask you to define the model, they basically want you to write out the equation. So here we're saying the response variable is internet use. So it would be internet equals to the constant beta 0 plus beta 1 times the GDP. Okay, so that's our model. That's it. That's everything you need for this part A. And then part B basically asks you to run this model, and then we're going to have all the solutions here. So let's run the model first. So we're going to analyze regression, linear regression. So we're going to put so the y is internet, y is the dependent, the independent is the GDP. Let's do OK. So first, the question asks you how many cases were used. So first, okay, there are a few tables. Okay, here they ask you what's the equation for the line. So basically ask you what's the number of beta 0 and beta 1. So based on the coefficient table, we have the first column, the unstandardized b, that's your beta value. Basically, this 61 is your beta 0 and 11 is your beta 1. So in my case, my fitted regression line would be internet equals to 61.179 time plus 11.710 times GDP. Okay. Oh, here usually we write there's an error. Okay. But when you have the numbers, you don't write out the error. So this is it. Okay. How many cases we used? So here, because for example, the degree freedom here is n-1, so we used 115 cases because here is 114. Okay. What percentage of, so here it asks you to insert a line to the scatter plot. Okay, the scatter plot we had in question 1. Oh god, where is it? We have the scatter plot here. So to insert a line here, you double click on this, okay? And then in here on top of, is it here? See here, add a fit line in total. So click on this, and this is it. Okay, so here this is the regression line, which is the one we just found. So you can paste this one here. Okay, this one. And then 5C asks you what percent of variation. So whenever they ask you what percent of variation, you go to the R-square table. So here the R is the correlation, and then the R-square here is 64. So we say about 64.7% of variation can be explained by the model, okay? And that's the value. Part D asks for a residual plot. Part E is about normality plot. And then part F asks you to comment on the assumptions. So similar to ANOVA, the assumptions we assume for linear regression is basically line. So we have linearity. So we're saying that the y and x has to be roughly normal. I for independence. So we're saying that the observations you have should be independent. M for normality. So we're saying the residual have to be, which we'll do this later, equivariance. Similarly, we're saying the residual has to have equivariance. So let's check these two assumptions, okay? So to check these two, we do regression again. So analyze regression, linear regression. In the plots option, plots, which first we do a residual plot. A residual plot is essentially a scatter plot with the standardized residual to be y and a standardized predictor to be x. So in here, the z predict, z stands for standardized. So z predict is the y, z resid is the y, and z predict is the x, okay? And then we do the normality plot for the part E. Let's continue and then let's do okay. So first, let's take a look at the residual plot. This is the residual plot, okay? The residual plot I have looked really bad, okay? So how do you look at the residual plot? So a few things. The residual plot should be uniform and symmetric. So uniform means that across the x-axis, you shouldn't be seeing any pattern. So here I see a very clear pattern. Say here it's like a nonlinear, and we don't have equivariance because the variance is very small here, and then the variance is very large. So this is clearly a very strong indication of violation of equivariance assumption. Similarly, for my normality plot, there's a huge trend here. So basically saying the normality assumption does not hold. Okay, so a little bit more on residual plot. So I'm going to show you a few examples of a residual plot. Residual plot example. Okay, so okay, here. So a good residual plot should look like this. So it has to be uniform and has to be random. Okay, if you see anything like this, it's a linear pattern, nonlinear pattern, increase of variance, nonlinear, and increase of variance. So all of this indicate a violation. So similar to our case, we do have a violation here. Okay, I think so we are saying for both equivariance assumption, and normality assumption, there is a strong indication of violation. So definitely the model does not hold, okay? And that's everything for question 5.